So Navy Pier, where I used to work, you can see it out my window. Let me just blow this up. And that's Lake Point Tower. See that? The only building east of Lakeshore Drive in the city area down here. It's all by itself, Lake Point Tower. And then that's Navy Pier going out into the lake. And then this is a beautiful area. And then this, let me shrink it back down a little bit. And then you get the lake view. And then you get the Shed Aquarium. And then let me show you behind me, as you can see in the mirror here. And that's the Adler planetarium. Kind of a cool looking as we go out into space. You know, I wonder if they have the Skylab, the space station, that you can see it through the telescope. And the Adler planetarium, as the space station passes over, they can see it with the telescope and you can view the space station. And they can also check on satellites. Yeah, the planetariums, the telescopes can watch satellites in that movement, and they can track satellite movements. So the planetarium can get revenue by tracking satellite movements. It can absorb objects like satellites and the space station moving over, and the planetarium can actually tell you what satellites are over the head of the city of Chicago at any moment. The planetarium. So if you're saying for security, the planetariums also work for military security, because the planetariums have the view of space, and in that space they have shape recognition, and that one telescope in its view can track many objects moving through and can identify them. But on each of those satellites, do they have signatures telling them what nation the satellite belongs to? What nation, what country, what corporation that the satellites belong to? Because they have to have ID tags on them, right? Some type of identification system. So, again, they can start tracking these objects, and at any time they can tell you exactly what satellites are over the city of Chicago. So, and then that's called national defense, and the planetariums, you have the U of A, Kids Peak in that. Not only if they look out into space, but they can tell you and track the satellites and how long it takes them to rotate over, and identifying which satellites are above. They can also use them to track planes in the sky, because they come in and the planetarium, their telescope, shows the planes that fly over and through the system. So they can make money for also being security. So they can identify any type of flying object. So think about this. You say UFOs, well, the planetariums can now integrate shape recognitions, and those things can start looking for UFOs. Even the radio telescopes are sending and receiving in space, but those radio telescopes that are receiving, also anything that breaks the beam, obviously gets in the way of the beam, is an object. So when there's a break or scatter of the beam, the radio telescopes can tell, and radio telescopes can tell if objects are moving in front of it. So remember that, because the beam will be interfered with, and there's nothing in front of them but an object. So if an object comes across them, whether it's an asteroid, meteorite, or anything, it will be noticed by the radio telescopes as well. But you have to integrate it into the system when it's not interrupted, and when it's interrupted, and be able to identify that interruption. So radio telescopes can track asteroids and objects moving in front of them. So radio telescopes can be used to track objects as well. Not only receive deep space communication, and they're needed to be receiving deep space communication when we send ships out. So those radio telescopes will eventually be needed for all the space programs. they would have to integrate with NASA so they can receive deep space communications. And I don't think they ever did that with Voyager and other satellites, but the radio telescopes could have received transmissions from incredibly deep in space from Voyager and Viking and others. And maybe they can move the systems that are set up to track the Viking, and the radio telescopes can maybe track Viking or Voyager that's way out there and listen for them as well. Because truly, and I don't know if Russia sent any deep probes out, and I don't know if China has, but I know we have, and now those radio telescopes can listen for them, truly. So they're listening for deep space communication. They can listen for Voyager and Viking. But they can also be used if the software is designed right in that. When they come in, the transmissions can track objects moving through space, like comets and asteroids and other things. So the radio telescopes can be used to track objects and track debris fields because they will interrupt single flow. And so there'll be a certain amount of interruption, and that tracks speed and everything else, but you have to test it here by receiving beams like you would from deep space and objects moving in front of it, and then how it causes the objects and the angle of the radio frequencies to change, and how long are they delayed, depending, it represents the speed of the object and so on. And so they can be used to track deep space communication, and we need them as we go out into deep space. Even tracking communication from the moon, the radio telescopes can. But the telescopes can also, intertwining them, working together, there's a national association, and we can use software to track objects like satellites and the space station and that. So we can always watch it as it's moving and look for objects that might be hitting it. So as it flies around, we can look for space debris. Yeah, even the planetarium can be part of that. But you have to be able to understand you need the software that can recognize these images within the telescopes, the images the telescope's receiving. But it can track space debris in that. So Kick Peak is the one at the University of Arizona, but they also have the one that's on campus. And so we can start linking together these radio telescopes and these satellites, telescopes, observatories like Adler planetarium, and they can watch satellites and watch the space station and track space debris and everything else. And so for national security, you say, well, they can tell you what's hovering over the United States, and they can look for UFOs, both for radio telescopes and traditional telescopes, if you're so afraid of UFOs. So it's another way to sync up the network and look for these unidentified flying objects. So we never did that, but we can, and now the radio telescopes plus the planetariums, their telescopes can be linked together, and they can look for all this different stuff moving in space, from Earth into space. And they can also, like I said, the radio telescopes for deep space transmissions. And we'll need them to be able to communicate with things deep in space. So NASA needs those radio telescopes, their listening posts, for deep space. And so I don't know if we can retask the listening in that. They can listen for Voyager and Viking and that. They have to know what to listen for. You got to give them the frequencies that they were transmitting on. But the radio telescopes can listen to them. I think they said they lost communication, but the radio telescopes, there's Super One in maybe Brazil or wherever in Latin America. They can listen for them better than what NASA has. And so we can reconnect with them as they are in deeper space. We say we lose transmission, but no, that's not it. We can use all these radio telescopes to get all this transmission. So I'm going to leave it here, but beautiful Navy Pier and the Ferris wheel and beautiful on the lake. So just some thoughts.